All right, let's get into some of the experiments that are claimed by mainstream to show that the system that we observe is heliocentric and actually supports the geocentric. Now, stellar parallax was described in 1832, and the diagram at the top here shows the heliocentric version of parallax. You have the sun and the Earth being shown in 6-month positions, January and July. We have a near star and a far star that, at least on my screen, is off the scale. But beyond the end, at the end here is the far star. So you need a reference line in order to establish parallax. Parallax is easily observed if you all take your right hand, extend your arm with the thumb up, and let the thumb cover some object on the other side of the room or maybe outside. You then close one eye, left eye, then close the right eye. And as you switch back and forth between eyes, you should see what apparently either the thumb moves or the distant object moves. And of course, neither one is true. What's moving is your location in the detecting the light. So all you can tell from parallax is relative position. You cannot tell whether something is objectively at rest or is moving. And that's an argument against what mainstream claims. But there's an even better argument. The diagram shows that when the Earth is in the January position and the far star is down here, you can measure an angle theta. When the year turns to July and the Earth is in this position, remember this is the heliocentric model, then the far star is over here, and this is the angle that you measure, the angle of parallax. This is what's always shown in the textbooks. Okay, remember that you must use the same reference lines. So what they're using is the sun, the near, and the far, the SNF. All right, here's the model of the geocentric system, the Earth at the center with the sun orbiting. Again, 6-month positions. When you sight the near and far star and use the reference line SNF, then you get the angle theta. This is the same angle by geometry as you get up here. The same would be true down here. When the sun is in the July position, the angle is theta, and that's the same as it is up here. So what am I saying? I'm saying that the geocentric model predicts the same angle of parallax as the heliocentric. But the problem that how can I say this? What they're doing is trying to impose a changing reference line when they use the geocentric model. When you use the geocentric model, you get the same results as with the heliocentric. So as long as the reference line is always SNF, both models will agree on the amount of parallax. Okay, you'll never see this in textbooks, which is the geocentric analysis of parallax.